20 days. I think we had the last session on 15th of June, 15th or 16th. So in the last session, we have just started with Unity. We started with the interface. Uh, we got to know about different tools that are available to us in Unity, what different interfaces are and things like that. So for today's session, we'll move ahead after that, and we'll look into some of the things that were left from the previous session, which was, I guess, importing assets and camera. And then we'll look into how to organize the projects in Unity. We'll start with an introduction to scripting in Unity, and we'll look at how we can move an object inside Unity by scripting some code. So before I start this, if there are any doubts from the previous sessions in installing Unity or anything like that, we can have 2 minutes of I'm waiting if anyone wants to ask anything before we move on, specifically in installing Unity or any of like getting familiar with the interface. If there's any doubt, we can wait for 2 minutes and then we'll move forward. If you have any doubts, please ask in the chat.
I think we can continue, sir.
Okay, fine.
Yes.
So this is where we were last time. This is the same environment that we had in the last session. We added a cube to the environment. We had a camera. We had a direction light. We added an empty game object, which I can delete now. I'll keep the cube because this is what we'll use in today's session. And let's start by looking at what assets mean. So the first thing that we want to learn today or want to see today is importing assets, right? So what are assets actually? What do assets actually mean? So basically anything that you are using in your environment, which are like say 3D models, audio, visual effects, these are considered as assets. So most of the time you will either there are two ways that you will be using assets. One is you will add some audio or 3D models in the Unity uh, uh, scene. So to do that, that is pretty straightforward. You basically whatever, let's say if you have an image or anything, you can just drag and drop it here in the project window in the assets folder. So this is the folder that is open here right now is the assets folder. So you can drag and drop anything over here, and that will basically add it to your project, and then you can use it. So I'll let me see if I have something that we can add. Any image to start with. So yeah, let's say I have this image. I just want to add it here. I can add it. I can just drag and drop it here, and now it's added to my project. And I can see that I can see the properties. I can change whatever I want for different models. So this is just for an image. The image extension is PNG. I can add images with different extensions. I can add 3D models. I can add audio files. So there are different supported file formats for audio and for 3D models. There are file formats like OBJ and FBX. So you can add those things by just dragging and dropping here. So that is one way. The other way is to basically delete this. The other way is to basically use something called as the asset store, Unity asset store. So this is the Unity asset store. and it is basically available at assetstore.unity.com. It is available on the web. In previous versions of Unity, it was available inside Unity, which like it doesn't. I think you. I am not sure if it's still there, but I don't think it is. They have shifted it. Uh, yeah, it's not there in Unity anymore. So you basically go to the web and you search for assetstore.unity.com, and then there are a ton of assets that you can see. So let's look at some assets. Like these are paid as well as free assets. So if I'll go to top free assets, and then I have standard assets, which is available from Unity assets only, Unity only. Then I have a 3D game kit. I have some terrain sample asset. So different assets I'll find. So let's say I want to use this in my project. I'll open this. This is an asset which is basically giving me some different materials that I can use while I'm creating terrains in Unity. So we'll look at what terrains mean and how we create terrains at a later stage. But this is a package that I can use for doing that. So let's say I want to add it in Unity. What I'll do is I'll just click on add to assets. I'll accept the conditions, the license basically, and then this will open up and I'll click on open in Unity, open Unity editor, and it'll open up here. Now I can just download it. Once I download it, it will give me an option to import it. So this is how you basically use the uh, asset asset store of Unity. The other way is package manager itself, which is available in under window under package manager. So you go to window package. Oh, asset manager, asset store is here. You can open from here as well. So this is what I was missing. But yeah, basically they have moved the asset store. You can't view it from inside it, and you can just search online and open it from here. So, but inside Unity now the method has changed, and basically you can view it from the package manager. So this is the manager that we just saw. A bit big. So it will basically hold few different things for you. Right now, what you're seeing on the screen are assets that I own in a sense. Own would be either I have bought them or I have free assets that I have used from the Unity store. So these are the assets that I have previously used and I own from the Unity asset store. So if I want to use them in this specific project, I can search for that in the packages, my assets. So this will basically show me the assets that are linked to my account, and then I can basically download and import. Let's say I don't want to use these assets. I want to use the assets from the Unity registry, which are basically some standard assets that are by default provided by Unity. So let's say I want to include, well, we'll be using ARKit later. So let's say AR core or ARKit, I want to install this. So this basically I'll go here and install it, and then this will give me an option to import it. So do I already have some packages installed inside the project? To check that, I'll go to packages and in project. So in project, I can see that I have some packages that are already installed, like test framework, text mesh pro, timeline, Unity UI, and some of these have this upgrade button on them. So if I go to that and I can update the package to the latest version as I wish. If not, I want to use the older versions, I can basically check older versions as well inside this, right? So this is how you basically manage the packages. Sorry, it's not showing the older versions, it's just showing which version is currently installed. But you can look at older versions somewhere. I forgot how to do that. I'll let you know this in the next session. But anyway, so try to use the most updated versions. But for some things, some specific packages, some projects, you might want to use an older package, older version of the package. So for doing that, we'll look into how we can install a specific version of the package. So this is about the package manager. Now, one more way that exists is basically using something called a package file. And to use that, I'll basically demonstrate how can we export a package that we have created in Unity. That like let's say I want to take this scene that I've created, this sample scene. I want to take this from here, and I want to use this in another project. So where is my sample scene kept? It's kept here inside the scenes folder, and basically it's sample scene dot unity. So dot unity is the extension for the scenes that we learned in the last session as well. So if I right click on this, and there's an option to export package. So if I click on export package, I'll get this option that I'm exporting the scenes folder, and under the scenes folder, I'm exporting the sample scene.unity file basically. So let's say I click on export. This will I'll export it to desktop, and this is basically creating a file of the type Unity package. So let's say I just name it test and I save it. So this basically creates a file test.unity package. Now, if I want to use it in any other project, let's say I just want to use it again here only. So there is again some different methods that I can use these files. So while using Unity, you will use Unity package files a lot, either to transfer your own things from one project to another, or to basically use some open source uh, project files that are easily available on the internet. Someone else has done some project and that is available on GitHub or somewhere else. So it will be mostly available in this form. So now to import this, one way is to basically go again here and click on import package and custom package. And I can click on test, and because the file, the scenes folder and the sample project, it's already in my project, it's saying nothing to import. But if I change the name of my scene to main scene and reload, and then I do that again, hopefully I will be able to see what are the contents. So I am able to see that there's a sample scene.unity which I exported. I'm able to import again. So now this is one way. The other way is again just to drag and drop it in my project folder. So if I just drag and drop it, again, the same thing will show up and I can import it. So this is the second way that I can import .unity package, which is basically just a folder for different things that I want to export from my uh, project. And again, like I mentioned, there are two major reasons for knowing this. One is basically because you want to shift something from one project to another project, or you want to reuse modules. So this is where you can create smaller modules of your project and reuse them in different projects. And the other is basically to a lot of open source projects and assets are available in the form of Unity packages instead of assets directly. So that's about basically managing assets in Unity. One thing I'd like to add to this is something called as prefabs. So prefabs are basically kind of blueprint or uh, blueprint to things that you create inside your hierarchy. So let's say I want this cube, but I'll be creating multiple versions of this cube, I know. So what I'll do is I'll create a prefab of this cube. So to do that, I'll just click on this cube and drop it here. So now I have so this is a prefab of this cube. So now I can, whatever properties I want to give it here, I can add multiple of these directly, multiple clones of this cube directly. And one more benefit of using prefab is that now I can export this as well. Just if I want to export it, I can export the prefab. And by exporting the prefab, I'll basically export all the values that are associated with it, all the components that are associated with the prefab cube, right? So this is one element that we should know, that we want to create prefabs for different reasons. One reason is to export the modular structure. The other is to for reusability. If you want to reuse something again and again, we can create prefabs. If you want to reuse the same thing in different scenes, we can create prefabs and things like that. So I will delete this prefab for now. I will unpack it and delete this. Cool. So that was about assets and prefabs. Next, what did we have today? Camera. So basically, I think in the last session, we saw some features of the camera that were that we were messing around with, we are playing around with. So one was we tried to one. There are two different uh, cameras in a sense that you are trying to manipulate. One is your final camera, which is your game camera. So this is your main camera, that is your game view. So this is basically everything that you view from here is your game view, and we'll come to that. But before that, whenever you are in this view, in the scene view, this what you're seeing is also basically a camera only. And you can change some things of the scene view camera if you want. So you can change the field of view. You can create dynamic clipping, which is basically when you go closer to an object, uh, how when does it start clipping? Is it clipping at like right now it is dynamic clipping. You can change that to what you want to change it to. Then occlusion culling is basically trying to uh, set occlusion inside the scene view itself. So basically, we set occlusion on the cameras in the game view, but we can set it and check in the scene view also. Then navigation, like these are some just how do we access the camera scene view camera settings. I can increase the speed, I can decrease the speed. So let's say I increase the speed and then I try to navigate a bit faster than I had earlier, and then I can uh, decrease the speed very slow, and now it's almost not moving. So this is about the scene view camera. I can change the minimum maximum values of the speed of basically this scroll bar, and I can have the different effects. So this camera is basically helping you to navigate inside the scene view, and this camera will help you to basically uh, you'll change these properties very not very often, only when you have created a big scene and you want to check some specific things, only then you will be changing these properties. But it's important to know that you can change these properties. Now coming to the game view. So this is the camera that we will be focusing on. This is the camera that basically you have or any player has in a scene, like any player would see through this camera. So at most, at least there will be one camera always available in the scene. Like, so let's say for a game which is a first person shooter game, the player is able to see the environment that is in front of him in the main view. And then there's, if you played any first person shooter game, there's a small mini map kind of a thing that displays a top view of the environment and the player's location and location of the buildings or location of the enemies around them, things like that. So that again is done through using a camera. So that camera is a top view camera, which is basically hovering right above the player. And as the player moves, that camera moves along with him and basically shows a limited area on that mini map. But what the player sees is the main camera, and that main camera is basically attached to the player. So I can attach this camera to a 3D object to the shoulder of a 3D object. So like if you have played games like Counter-Strike or any other first person PUBG or whatever Fortnite, these games, you'll basically see that you see half the body of the player in the first person view. There's a third person view where the camera is a bit behind the player and you can see the full body of the player. In the first person view, you either see just the hands or just half the body, and you're basically viewing from here somewhere. So basically, depending upon where you place the camera on the 3D model, you can manipulate this scene from like basically manipulate the scene. Either make it third person, first person, top view, different kinds of views. Basically that basically you can do from the position and the rotation. So this is one part where depending upon what kind of game that you want to create, you can change the attach the camera to the player and then basically use the transform properties of the camera to manipulate how it looks to the player. Now coming to the properties of the camera itself, I have something called clear flags. This basically means what is the background that the player sees. So like right now it is kept as skybox. Skybox is something like which is at available, which is displayed at infinity. We can change the skybox and we look into it when we look into lighting specifically. So, but for now, you can see understand that whatever like the thing that you're seeing here right now, this blue sky and the brownish earth texture basically, this is the skybox. So something that is available at infinity, the more you move towards it, the more farther it goes. Like it does, it you will never reach this the edge here. Basically, that's what I mean when I say infinity. So this is available at infinity, and this is basically a outer covering or outer background to your environment. So I can change this to whatever I want. Let's say I want to change it to solid colors, and then this is what my camera will show in the background. I can change it to white. I can change it to like I can change the colors of this as well, depending upon what I want it to display, right? So background basically is doing this. And let's say I just go back to Skybox and yeah, so this is what uh, clear flags and background, the combination of this is what you'll do. Then there's depth only, which will basically just show you the objects that you place in the environment. This is basically used in some AR experiences. So black environment, like whatever you see in black, this will become the actual real environment and not show you this blackish when you are playing in AR. So that is where this is used. Let's go back to Skybox, and then we have culling mask. So this is basically like what things that you want to see. I can in the environment. If I create check on everything, I'm basically seeing different layers. So these are layers that are there in the environment. Like from here, I can see which layer what object is on. So I can specify some objects that I don't want to see. So this comes in handy when let's say I create uh, a mini map kind of a situation and I don't want to show some specific layers. Like I don't want to show uh, the player's 3D model in that camera view. I want to show a triangle instead. So I'll keep that triangle in the layer that I want to show, and I'll remove the player from the layer that I'm showing there. So I can basically control that what I want to show in a specific camera through this culling mask. Then there's projection, which is basically what the kind of camera you are using, perspective or an orthographic. So this basically changes a bit of how the camera looks. This will show it better here. So a perspective camera basically has a wider, uh, you can say, field of view, or it's a bit different. Like it starts from a smaller plane and there's a bigger plane, and whatever that bigger plane is seeing, is projected on the smaller plane. But in an orthographic camera, it's like the size of the orthographic camera decides what you're seeing. So this is like you'll kind of restrict the 3D view of the environment in this. But this is also used at some places. Again, like the minimap, you can use orthographic cameras and some other places. So like if you see in perspective, there's some 3D component that you can see here, right? But when I change it to orthographic, it's almost as if it's 2D. So going back to perspective, now again I have field of view. I can change which axis field of view I want to change. If I change vertical, I'll increase this, decrease this. I can change horizontal field of view, increase this, decrease this, right? Going back to what I had, then there's an option to create a physical camera, which is basically the field of view is calculated from the properties for simulating physical attributes, focal length, and I can basically, I'll have these properties and the field of view is calculated from these properties like I have in a physical camera. So if you want to use, set up some specific, like a game where you want to give the user access to these and change the way the user is interacting with the environment based on some focal length and different cameras, different these settings, then you can use this physical camera as well. Again, going back to the previous settings. Uh, so yeah, and then there are some settings that are here which we'll look at later. Some like things like uh, target texture, which again is used when creating a thing like minimap, occlusion culling. Uh, so these are some things that we can talk about later slowly when we are specifically using these. Target displays are basically like, let's say you have a monitor, three display monitor setup, which are available at some places, then you can basically set where to display this camera. Like if I want to create a game which runs on three monitors at the same time. So I have a, let's say I have a flight uh, air traffic control simulator. So I want to create a scene where one screen is showing me a map view, one screen is showing me a first person view of a plane, and one screen is showing me some random data. So I can use which display to display what on. So if I click this on display one and I change the display from display two, I'll see that no camera is rendering on display one because I can check displays from here as well. So this is just something that you can change. Then there's an audio listener. Whenever you create a camera, there will be an audio listener attached to it. This is generally because the camera is associated with the player. An audio listener is basically trying to look for audio sources around the scene. So audio listener is basically your, in a way, your ears inside the environment, which is listening to any audio source that is playing anywhere in the environment. So you can place audio sources in the environment. Let's say near a tree, you have placed some wind kind of an audio. So when you go near that, you can hear the wind through this audio listener, but the source is kept near the tree and it's a windy environment and things like that. So this is basically whenever you create a camera, and these are some things that you definitely find. Right. So this concludes about the camera. Next is organizing projects in Unity. So basically, what do we mean when we say organizing projects? Like we talked about just some time back, it's important to create modular projects so that basically you can uh, take some smaller modules from this project and use it somewhere else, or share some specific part of the project from your project with someone else. So things like that. So to do that, as well as to basically be organized in a very big project, it's important to know how to organize your projects in the environment. So one way of doing that is basically to create folders and segregate everything properly. So like right now, I only have one folder in my assets folder, which is called the scenes folder. Now, like let's say I created the prefab of this cube. So I'll just keep it here in the assets folder, and then I import some audio files and I again keep it here in the assets folder. So eventually I'll realize that a lot of different things are existing in the same subdirectory, and I don't have a organized way of looking through those, uh, looking through or searching through those assets and through that directory. So what I can do is basically create subfolders first of all. So like let's say right now I want to create a folder for, because next we'll look into scripts. So I'll create a folder for scripts. I will create a folder for materials. So this is something that we should do, basically create different folders. Next, what we should do in the specifically for scenes is basically number your scenes. So like let's say I want to make this scene 0. I can, why do I want to number it? Is basically when I build this, when I build the scenes, I'll have numbers assigned to it. So if I have a project where I have let's say 15, 20 scenes, I should be aware of what scene I'm working on, what scene I'm supposed to work on next, things like that. So like this is where I'm building it. Build basically means creating the package. So if I add open scenes, so I've added 0 main scene here, but I also, it automatically assigns a number here as well. So in the sequence that it's supposed to come up, generally it'll be like this only. There are some projects where you can have additive scenes. So a single scene will single time at a single time you can load multiple scenes as well. So for that you can create a sub numbers. So 0 point something. So you can do things like that when you are creating scenes. So this is one way to keep your project organized. Next is to basically whenever you add uh, a material, like whenever you add an asset, like let's say it's an audio file. So keep a suffix or a prefix in your assets that you add. So like let's say you're adding audio files. So whatever audio file you add, so start it with AUD underscore and then the name of your file. So whenever I want to search for the audio file, I can just go here and search AUD, and it'll show me all the audio files, not anything else. If I want to add materials, I can add MTL underscore then material. If I'm adding some images, then I can add IMG. So depending upon what I'm adding, I can basically add a suffix or a prefix. Generally, preferably is prefix. Suffix can be for some other part. So basically, nomenclature is important, and that is one way to keep your projects organized. So I think we'll talk more about organization and uh, more more on this once we start building more things. So next move on to starting with scripting and what all do we do in scripts and things like that. So like for now, let's just open our scripts folder. This is where we'll create our first script. I'll right click and create and C# script. For now, let me just name it test and open it. So there are, you can basically attach whatever script editor you want this file to open in your, just a second. So if I go to edit and preferences, I have external tools option. So I can select which external script editor I want to attach it here. I have Visual Studio and Visual Studio Code. So I can attach Visual Studio Code as well, which is a lighter code editor. And if I want to add some other editor as well, then I can add it here also. But just make sure that whichever code editor you use, they are able to basically support Unity debugging, Unity C# debugging, so that while you are writing the code, get some idea of if you're writing something wrong, or you'll get suggestions while writing the code. Let me zoom in a bit. I think this is more visible now. So this is how your code will look like whenever you open your file. So I've opened up the test.cs file. .cs means C#. So I have some headers here which are using system.collection. So that whenever you create a script, C# script, these things would generally be created with it. So you will have using some headers which would be using systems.collections, systems collections generic and Unity engine. So these are some classes that exist already in Unity, and this will help you code some of the basic things. Then we have a class that is created, which is named similar to the name of the file. The test class is created because the name of the file that we gave was test. Then this is basically inheriting from the mono behavior class, or basically extending the mono behavior class, which is your most basic class that is available in Unity. And whatever functions that you write in Unity will be an extension of the mono behavior. So there are a few functions that are there existing. Two functions it shows us. One is start and one is update. So what does start, what does update do, and what other functions are there? So start is basically a function which is called before the first frame update. So start is only called once whenever your program runs, and it is basically called before the very first frame update. So let's see if this actually works. So I'll just use print for now. There's a function called debug log as well, which I can use, but I'll use print, and I'll print something called start function working, and I put a semicolon. Save this, and then what's this? Move back to Unity. I have a test class here, and now I play this. So now you'll see that nothing really happens. Even if I'm in play mode, nothing is being printed, nothing is showing, right? Why is that? Because I've not attached the script anywhere. I need to have the script in my hierarchy, in one of the objects in the hierarchy, then only something will happen. So how do I do that? There are again two ways of doing this. One is you go to whatever object you want to attach the script to, go to add component and search the name of the script. So I'll do test. I can attach it like this. So now if I've attached it, now I go to my console because it will print. When I play, it prints start function is working. The other way to attach it is, let me remove this, and basically just dragging and dropping it to where I want to attach it, right? And this will basically again give me start function working. In the console, we learned that we can clear it as we like. And then let's go back to the script. So now we know that start function works once, and it's basically I printed start function working in the start, deleting it, and then looking at the update function. So update function, it's written that update function is called once per frame. So now let's try it, what update functions does. It working. Then if you see, it is basically running and giving me like printing the values every frame. So if you see the number here, it is increasing every frame. So it's just printing update working every frame. So that's all. So basically, what we understand from this is that the update function, it runs every frame. So depending upon the frames at which your game is running in your on your PC, 15 frames per second or 30 frames per second, depending upon your refresh capability of your system. It will run those many times per second, right? So it's not fixed how many times per second an update function will run, but it will run every frame. Now I can remove this as well. So are there any other functions available in mono behavior to us? Yes. And let's have a look at what kind of functions we have apart from start and update. So this is something that will help you a lot everywhere, which is basically the Unity manual. You can search, sorry, search for docs.unity3d.com manual, or you can just, whenever you have a doubt, whenever you have to look at a specific thing, just Google Unity manual and then that specific thing that you want to look into. So this is basically the execution order of execution of the functions that we have, and some of the functions mentioned here I'll mention, like we'll talk about only few functions right now. So I'll talk about awake. So awake is a function which is similar to start, but it's an initialization function which runs even before start. So first up awake will run, then we'll have start, which is also just once per frame. Then we have the update function, which is down here. And similar to the update function, we have a function called fixed update. So for our update function, basically we found out that it runs once per frame. Fixed update is also similar, but it runs once per physics cycle inside that frame. So basically, when you have something that is dependent on the time, or it's supposed to run similarly on different systems, or any physics function that you will run, that Unity runs by default, like let's say collision testing and things like that, that runs inside fixed update. If there are things that you want to test uh, inside for physics, then you'll run it inside fixed update. So eventually you will learn there is very subtle difference between update and fixed update. So you'll learn where to use update and where to use fixed update. Then there is a function called late update as well, which runs right after update, but also runs every every frame. And then there are decomposition functions. Most important is on destroy, which we have a function called destroy, and we destroy some game objects. This is a function that runs at the end. And there are a lot of other functions between these, which we'll look at specifically step by step. But this is a general complete framework of all the event functions that are available to us and what is the order in which they are executed when I write them in my code, right? So you can check this out. Just Google Unity order of execution and you'll come to this page. So now let's look at some code, and specifically what we want to do today is basically we have this cube. I'll delete this specific code. I don't want to keep this anymore. I'll remove it from here. I'll go to my scripts folder and I can delete it because doesn't is not required. But now I want to create a script for moving objects. So what object do I want to move? I want to move this cube inside the environment. So there are a few different ways in which I can move this object. Let's see how. So I'll create a new script. I'll call it move object and I'll open the script. So I've created the move object class. This is again a nomenclature uh, generally followed, that the name of the class should be in all caps in the sense like all first letter should be caps. Name of the function also first letter should be caps. When we create a variables, they can have a camel case, or depending upon uh, what style you follow, generally camel case is followed. So to start with, let's see what kind of things that we can do. So I have some pre-written code here. We'll check it one by one and see what all the different things that we can do. So initially, let's see what this first line of code is doing, and I'll paste it in my start. So what is it doing? It moves an object to the set position. So what I'm doing is basically I'll attach this move object code to the cube so that when I do transform dot position, it is basically getting the transform of the object that it is attached to, which is the cube. And from that transform, it is getting the position. So like, let me go back to Unity. When I go to cube, I attach the file here. Now move is attached to this. So this is the transform of the cube. So when I click on write transform, this is the object that is, this is the component that is being referred to. When I say transform dot position, I'm getting this XYZ position. Now what I'm doing next is basically creating a new vector which is holding XYZ values. So which is holding 10, 0, and 5. Let's save this and let's see what happens when I play this code. Pay attention to the cube. Right now, the position of the cube is 0, 0, 0. When I press play, the position changes to 10, 0, and 5. Right. So, and this only happens once because I have placed it in the start function. This code runs once, changes the position, and the code stops. Now coming back, let's try one more function, which is basically to move the object, continuously keep moving the object, right? So now what we want to do is move the object. So move an object 2 units up. So again, what we are doing is we have taken transform of the cube dot position. We are referring to the position, but here we are not doing equal to, here we are doing plus equals to. So plus equals to basically mean transform dot position equals to transform dot position plus new vector 0 to 0. So what we are doing is at every frame, we are adding two values in the y direction to the existing value of the transform position. Let's save this and see what happens when we play. So what happened is initially it went to the 1005 location, and now if you see the y value keeps on increasing with the limit of with an increment of 2 at every frame. So as long as I keep it running, it will keep on increasing, keep on increasing. There's no stopping mechanism as of yet. Coming back here, let me remove the start code because we don't need that update. And if I go back here and just start from the center, now I am not changing the value uh, initially in the start, and it's just going up. So that's there. Next, what I want to do. So this is one way where basically I am uh, controlling the movement of the object. So first we saw how can I change the position of the object. Next, what I did was control the movement of the object at a specific uh, interval. How do I keep on changing that position again and again, right? Now what I want to do is basically uh, control the time that I change that the movement happens. So what I'll do is multiply it with something called time dot delta time. This is basically to smooth the movement as well. So what time dot delta time means is the interval in seconds from the last frame to the current one. So what it will give you, the value that this gives is basically interval, a very small float value, which will basically be the interval in time that your system takes to run the interval from the end of the last frame to the beginning of the current frame. So this interval of time is your time dot delta time. So basically the difference of time between two frames is the time dot delta time. Now, why do I need this? So this basically helps me create a similar uh, movement effect in every system. So by using this, I am eliminating the dependency on the frame rate, which I had when I was using just the position movement, when I was using in the when I was just using transform dot position and adding some value to transform dot position. Now by using this, I am adding a value which is dependent upon the specific difference in the frames at each frame update. So by using this, I am making sure that the code that runs faster, or like the code that runs while it is running on a faster frame rate, like let's say 30 FPS, the same code will run. The code will run similarly on a system with 15 FPS. So now if I go here and if I play, it'll move a bit slower and the movement is smoother, right? So if you can see here, it's moving up slowly because I've multiplied the value with time dot delta 10. So coming back here, what do we have next? We have, so now let's say I want to basically do this, but I want to keep on changing the speed. So I will basically create a speed variable rather than doing this with just this. So for that, what I can do is like I have a function called translate, which will come to next. But let's say I just create this variable called speed and I add it here. So right now I've given this variable a value of 2 and I can just multiply it here. So into speed. And to see it properly, let's move it in a different direction. Let's move it in the Z direction. So now when I go here, I see that I have a variable called speed. So I will first change the value of the speed. I can change the value of the speed variable from here itself. So whenever I create a variable inside the script and call it public, then this variable will show up in the inspector window here in the component in the script component. But if I create it as a private variable, then this won't show up here. But for some private variables, I want it to show up. I want the variable to be private, but I also want to see it here. In that case, what I can do is basically create it as a serialized field. And then it will show up here. So it shows up here. So I can create either a public variable if I want, if there's no security issue, if there's no issue by creating it public and any class can access it. So basic OOPS object-oriented programming we have studied, and we know what different access modifiers can do, what are the uh, benefits of having access modifiers, what is the benefit of having a private field, what is the benefit of having a public field, things like that. So let's say I want to keep it private, but I still want to see it in the inspector window. In that case, I can basically create something called a serialized field. And I am basically serializing a private field. So this means that I am able to see this in the inspector window. Saving this, going back here, I change the speed to 0.5 and then I play this. And I've changed the movement of direction from up direction to the forward direction. So if you see, it's moving in the forward direction at a very slow speed. Now let's say I change it to 50, all of a sudden it starts moving fast. So now I can use this variable in some other code and I can manipulate the speed based on, let's say I want to change the speed based on the player's performance. So if the player is performing well for, let's say, 5 seconds, then I increase this speed by 0.1. If the player is performing poorly for the last 5 seconds, I decrease the speed by 0.1. So for games like Subway Surfer or Temple Run, you've seen that when the player keeps on running for a longer distance, the speed slowly increases. So this is something that can help you create games like that. So now coming back to this, right now what I did was again in the same value that I had before, I gave this as my direction. So this is the direction value that I gave. This is the speed value that I gave, and this is the basically to manipulate the physics or to control the frame rate, right? So looking at what next I have something called a transform.translate variable function. So right now I was basically using the transform.position function to do this. Now I can use the transform.translate function to do the same thing. So going back, I will replace all the code that is here and paste this. And now what this transform translate function basically do is basically moves the object that you are attaching this code to in the direction and distance of the translation. So I am inside here and defining this same thing that I had defined earlier. So vector 3 dot forward is similar to 001. Speed I am designing here again, and time dot delta time is something that I explained. So vector 3 dot forward is basically 001. Vector 3 dot back is 00 minus 1. Similarly for the other things, up, down, left, right, defining the direction of the thing. So similarly, you will also have transform dot forward, backward, and things like that. So I'll come back to this. So now what does this do? When I save this code and I go back to Unity and let's make the speed 4 and let's play it. So it has the same effect as the previous code, but it's just using a function called transform.translate, right? And again, for this also, I can increase the speed and everything can be done. So again, coming back to the code, now let's look at what we have next. So we have something called like the thing that we were using before, the transform position, but we can use it with instead of using with the values that we were creating. So we were using it with new vector 3, but instead of doing that, we can, if we just want to give the direction, then we can give the direction with respect to its own self and relative to its own uh, position and rotation, relative to basically its own transform, and we can use the values forward, up, and right. Forward, up, and right transforms, and negatives of those will basically become back, down, and left. So I'm not doing this, but you can try it on your own. So now let's next, one more thing that is left for us is to now control the movement using the keyboard input. So to do that, I will copy this code and go here, replace this. So now if you see, I have a code where basically I'm taking two values, X and Z. In the X, I'm getting input.getAxis. So input is basically a interface to the input system. GetAxis is a value which returns the value of the horizontal axis. So horizontal, as you see here, it's a string. So how does the system know what horizontal actually means? So I'll go to Unity. I look at edit, project settings, and input manager. So here I'll see that there are axes that have been created. There are 18 axes that I have: horizontal, vertical, fire 1, fire 2, and there are different things that are there inside this. Name, negative button, positive button. So this is left arrow button, right arrow button, A, D, and some gravity is defined, sensitivity is defined. So you can look at what these things mean on your own. But most important is that the horizontal axis is basically left right arrow keys and A and D buttons. So if I press A, that is negative value, D is positive value. For vertical, I have up and down arrow keys, and negative is S is negative, W is positive, right? So uh, coming back to this, so I am basically taking the value in update. So specifically at each frame, I am taking the value. If the button is pressed, W, A, S, D, or up, left, right, down arrows are pressed, I'll take the values in X and Z. I am creating a new vector because uh, I'm creating a vector called movement, which is basically creating values from X and Z. And then the values, I'm using the function that I had previously and giving it the vector that I created. So just for viewing, let's see what this movement is. So we'll print this movement as well to see what this vector is being created. So now let's save this and move back to Unity and go to console, and I'll change the speed to 1, or let's say 2. So now as you see, 000 is being pushed here because right now the values are not there. If I start pressing W, you'll see that the cube is moving forward, and the value that is being pushed here is 001. Now I'm pressing S. The value is 0, 0, -1, and the cube is coming towards us. I can similarly press S. I'm pressing A right now. So A is giving a value of -1. D is giving a value of 1. I can press two buttons at the same time, create a diagonal movement. So now I'm basically controlling the movement of the cube using my keyboard. So this is through WASD as well as through arrow keys. Now I'm using the arrow keys. So I'm not displaying it what is being clicked, but yeah, you can test it out. So that's about moving it with the uh, keyboard. So this input system is an old input system. There's something called as new input manager as well for Unity, which we can look into at a later stage, or you something that you look at your own, which is basically a more enhanced input system with key bindings, and basically you create a binding for one device, and you can create bindings for different devices. So like you can use similar code for keyboard. Like right now, if I want to use this code for a joystick controller, I will have to change some of the things in the code. I'll have to add new accesses, things like that have to be changed. But if I use the new input package, I can basically write a single code and create key bindings for different devices that I want to use. So yeah, next, this is the last code we have for today, which is basically using physics and then moving the object. So I will add this code here, and then I'll explain what is what. So here we see that we have two variables. One is rigid body RB, and one is a force amount. So force amount is straightforward, that this is the amount of force that I want to apply to the object. Now, what is the rigid body? Rigid body is basically uh, any whenever you want to control an object's uh, can apply any physics on an object, you will basically use a rigid body. So rigid body is a component like other components that we have been seeing till now, like transform or camera component, audio listener. So rigid body is a component that is applied on the game object, and we can basically control the physics of the that specific game object through this rigid body. Then what are we doing here? So we have used fixed update, like we talked about. Whenever you're doing some physics functions, use the fixed update. So because we are using rb.add force, so rb is the rigid body and add force is a function that is available to this variable. So inside rigid body we have a function called add force. In add force we are defining the amount and direction in a sense. So amount is multiplied to the direction is up. So let's save this code and go back to Unity. We see that the variables here will change. Now we have a public variable called RB and we have a force of 10. So now if you see here, the RB says none, like no rigid body is attached here. Now if I play, what happens? It'll give me a unassigned reference exception, right? Because I don't have a rigid body attached here. To do that, I will basically add a rigid body component. For now, basically, there are things that you can basically define in the rigid body: mass, drag, angular drag. We can look at this later, but for now, I'll change the gravity to not using gravity and then add the rigid body here. So I can basically access this in code itself, but just for access, right, easy access right now, I have just added it here like this, and then I press Q. So now basically this is the same movement thing is being applied, but it is being applied at every frame, a force of not every frame, every physics frame. So after every set interval of time, a force of 10 is being applied in the upper direction. So if you see, it still keeps on moving. So that's how you apply physics force to an object and basically moving an object using force. So that's the code for that. And that's all of the code that we had to go through for today. So that's it. That's all for today. And if there are any questions, we can have them in the chat now. This is where I'll stop for today. Any questions, anyone?
If anybody has questions, do put them down in the chat box. And just as a reminder, the attendance link is live. So please fill it as soon as possible. Thank you.
So fine, if there are no questions, I'll take your leave. Thank you everyone for joining, and we'll meet next probably on Monday. I'll update you. Thank you. Bye bye.
Thank you, sir. Good evening, sir. Uh, I request again, those who are done, please fill and leave. Uh, Thank you.